We have seen in the last class that atoms have their valence electrons, okay, and they try to complete their valence shell, and that's the Lewis octet rule, okay, or it is also known as Lanimer-Lewis theory, right?
Yes.
So basically, the atoms are trying to complete their octet, and that is through sharing, okay, that we have seen. Clear?
Yes.
What was the other way to complete the octet?
The balance, like sharing and donating or
One was
giving.
sharing, right? Another was suppose if there is a metal and a non-metal, then it is by the complete transfer of electrons from metal to non-metal. Okay.
Yes.
So metal is going to give the electrons, right? Lose the
Yes.
electrons and form a cation. How many electrons metal will use?
Mm, it depends.
So metal you will write, for example, sodium you have seen 281, okay. So this is the outer shell, and outer shell metals have just 1, 2, 3 electrons, okay, and they lose their electrons, they form a cation, okay. So you will remove the outermost electrons, so that you are left with 2, 8, right? The inner shell. It is very difficult to remove these inner electrons because, as you can see, that these inner electrons will ionization energy is going to be very high. Okay, is it clear?
Yes. Yes, sir.
So basically, this electrons to it will so sodium will lose first ionization energy will be very low. It is a metal. Okay, it can lose 1 electron. The second will be very high because the second electron is removed from the inner shell. Okay, which is complete. Okay, so just check how many electrons are there in the outermost shell. They will be either 1, 2, depending upon the group number. Group number 1 will have 1 electron. Lithium, sodium, potassium, rubidium, and cesium. That is the first group of the periodic table. Group number 2 is near adjoining that, right? Beryllium, magnesium, calcium, strontium, barium, that will have 2 electrons. And then the P block aluminum is there, that is 13, so 3 electrons will be removed, right? So likewise, you can remove the electrons, outermost electrons. You can form a cation, and those electrons can be given to anion, non-metals. So non-metals will form anions, right? Is it
Yes.
clear?
Yes.
And they will form anions, and cation and anion are held together by electrostatic force of attraction. Cation opposite charges, they are going to attract each other. What is electrostatic force of attraction, Abhina?
So electrostatic is the force that is the total amount that is required for reducing or like where an
Actually,
atom.
it is the attractive or repulsive forces due to their charges. Okay,
Yes.
and if you have opposite charges, it is going to be, if you have opposite charges, it is going to be attractive. Got it?
Yes.
Clear? And if you have same charges, it is going to be repulsive force. Okay, so cations, metal will form cations, non-metals will form anions, They will attract each other. Okay. But make sure that whatever the charge of the cation is, that is balanced by the charge of the anion. Okay, totally clear. So that is
Yes.
electrostatic force of attraction, and this bond, this force of attraction, is known as ionic bond or electrovalent bond. Got it?
Yes, sir.
Ionic bond or electrovalent. So I hope this is clear. Okay.
Yes.
So actually, molecules try to complete their octet. Okay. Valence electron are represented by dots, and if there are two nonmetals, generally if there are two nonmetals, so they will try to overlap their dots to complete their octet, 8 electrons. Okay.
Okay, sir.
And they will form bond through covalent bond. Got it?
Yes.
So that's what we had seen. So, and suppose if there is a metal and a non-metal, then the metal will completely transfer the electron. Okay.
Mm.
And it is going to form a cation, and completely accept those electrons, it will form an anion. They will be combined with the help of ionic bond or electrovalent bond. Is it clear?
Mm.
Right? But we have seen that not all atoms have complete octet. Got it?
Yes.
What was the real reason for covalent bond formation? What was the actual reason for covalent bond formation?
Mm.
Was it the completion of the octet?
The stability.
Yes. So it is the attainment of stability. Exactly. Okay. Sometimes in the sometimes in covalent bond also you will see the charged species. Okay. For example, how we are going to form CO3 2 minus. Are you getting the point?
Yes, sir.
So carbonate, this is carbonate ion, right?
Yes, sir.
Where do we see it?
Mm.
Carbonate ion, we see it in calcium carbonate, right?
Mm.
Uh, Calcium carbonate actually CaCO3. So how to show the bonding of this? Got it? Are you
Yes,
getting the point?
yes, sir.
So how will you show the bonding of this carbonate ion? Tell me. That
Mm.
is,
So,
yeah, you can tell me first.
what, sir?
Yeah, how will you try to draw?
So C will be in the center.
C will be at the center exactly. And how many electron do I need to show?
Electrons are uh,
Atomic
in.
is 6, right?
Yes,
Carbon.
sir.
So 2 and 4. Got it? So 2
Yes.
valence electrons. What are the other groups which are bonded to carbon around it?
Oxygen.
Oxygen. Are all the oxygen as oxygen atoms, or there are some of the oxygen connected as oxide ions?
Mm,
Look at the charge of the carbonate. With that, you will be able to make out. Getting a point? What is the charge on the carbonate ion?
charge 2.
Hmm? Carbonate is -2, right? Means actually there are
Yes.
2 electrons extra. Got it? So actually there are 2 electrons extra, and so take one as oxygen atom. Oxygen will have it is the 8th element, so it will have 6 valence electrons. Got it?
Yes.
2 and 6. And take 2 oxygen as oxide atom. Got it?
Mm,
Oxide ion, how you will write? O minus, it will be having 7 valence electron. Is it clear?
yes.
This is O minus and this is O minus. Are you getting my point or not?
Yes.
So I have taken 2 O minus, right? And 1 oxygen
Yes.
atom. And how I got the idea?
Because of charge.
By charge, right? So this
Yes, sir.
oxygen has 6 electron, it need to share 2 of its electron, 2 more, so it will share 2. Because it want to become 8, so it will share 2 more. But so this oxygen is going to form the bond with the carbon, right? This is the
Yes.
oxygen which was not carrying any charge. Is it clear?
Yes, sir.
And how many more electrons are required by O minus?
One more.
Yeah, one. So this O minus will share, right?
Yes.
It's 1 electron. One more, so it will share its 1 electron with the carbon, 1 electron of the carbon. Got it?
Yes,
And
sir.
similarly here also. Clear?
Okay, sir. Yes, sir.
So you will be having got it?
Yes, sir.
This is known as the formal charge. Formal charge is basically it is the charge on the atom. And how can you calculate it? It is the total number of valence electrons which element has, okay, as per the atomic number,
Okay.
right?
Okay, sir.
Minus the bonded electron minus the lone pair electron. Actually, the basic thing is you need to compare the electrons. If you don't remember the formula, just a quick trick is how many electrons this oxygen is carrying. lone pair electrons belong to oxygen itself, right?
Yes, sir.
Is it clear or not?
Yes, sir.
Then you have one bonded electron, one is of carbon, another is of oxygen. Clear? So bonded electron, you need to take half of them. Is it clear?
Yes, sir.
So valence electron on the oxygen are 6 minus bonded electron pair were 2 by 2, right? 1, and lone pair electron are 6. Can you see 6? 3 lone pair and 6. Is it clear? So the
Yes, sir.
charge is minus. That's why the oxygen is having the negative charge. Is it clear?
Yes, sir.
Valence electron on the oxygen atom, half of the bonded electron minus lone pair electrons, which an atom is having, that will give you the charge on the atom.
Okay.
This is how you are going to get the formal charge on an atom in a molecule. Clear?
Yes.
For example, what is the structure of NH4 plus?
Um, N in the middle
Hmm?
and N in the middle,
Yes. So
and there
N
are
in the
5.
middle, yeah, you have 4H. Okay, right?
Yes, sir.
This is okay. Normally, you can also think it in this way. Nitrogen is how many electrons?
Nitrogen 5.
Nitrogen is 5, correct. So 5 electrons are there on the nitrogen.
Yes, sir.
Hydrogen is just having 1 electron. So I bring 3 hydrogen atoms, right? This is how ammonia is prepared.
Yes, sir.
NH. Okay. Now
Yes.
we have just this is for the ammonia, not for the ammonium ion. Okay. How can you get ammonium from ammonia? How can you get it?
Mm,
You need to attach one more thing. What is that thing? Getting my point?
mm,
Yeah.
the charge.
Yeah. And one at H plus or H minus, you can attach H plus. Got it?
Yes.
H plus because you need to have plus charge, okay? And
Okay.
so one atom, like in the above case, we connected to O minus, right?
Mm,
So now you bring in H plus. Okay, if you connect it, one thing is sure. What it is? If you actually bring in the H plus, okay, one thing is sure that H plus is not having any electron. Got it?
yes, sir.
Is it clear or not?
Yes. Yes, sir.
So, and ammonia is having the electrons. So normally till now, what we have seen, till now we had seen that normally both the atoms actually bring the both the atoms bring their electrons and they participate in bond formation. Is it clear?
Yes, sir.
But in this, there is a different situation. What is the situation?
We added the hydrogen plus, which is already
There is one atom which has complete octet, nitrogen,
yes.
and there is other atom which is not carrying any electron at all.
Mm,
Okay. Till now we were seeing that if two atoms are participating in bond formation, so both of them should bring their electron and they should form a bond. Got it?
yes.
Clear? But now
Yes.
the hydrogen is not having any electron. So in such case, we will see a new type of covalent bond formation, and that is known as coordinate covalent bond. Got it?
Mm,
Coordinate covalent bond is formed when both the bonded electron pair are contributed by one single atom only. Is it clear?
yes.
So look how it may be forming. So nitrogen is having a lone pair, right, which is not being used. So what will happen? This nitrogen will let its electron to overlap with the hydrogen. Got it?
Yes.
Are you getting my point?
Yes.
Look, this nitrogen, nitrogen electron and the electron of the hydrogen, but there both the electrons are given by nitrogen itself. Is it clear or not?
Yes.
So now the plus charge will be on the nitrogen. Okay. You
Yes.
can write it like this, or you can write it in this manner. Put an arrow from the atom
Okay.
taking the electron to the atom which is taking up the electrons.
Okay.
Is it clear?
Yes.
This is known as coordinate covalent bond.
Okay.
Is it clear or not?
Yes, sir.
Coordinate covalent bond. So just tell me what it is roughly. Quickly tell me.
It is when an already uh, atom which has already been completed its octet rule will join.
Yeah, and there is another atom whose octet is incomplete. Yes,
Yes.
and what they try to do?
To
Yeah, actually,
stabilize.
so the atom whose octet is complete will share its electron pair. Both the electron pair are shared by that atom only. Got it?
Okay.
Is it clear or not?
Yes.
So that is how the coordinate bond is being formed. So both the atoms are contributed by one atom only. Got it? Clear?
Yes, okay.
Okay. So just try from your NCRT, the examples, of more coordinate bonds given in NCRT, right? So
Mm,
now uh, we have seen the formation Lewis octet rule, right? But be careful that this octet rule is also violated. Okay. And why it is violated? It is violated because sometimes you have certain elements which have more than 8 electrons, okay, or less than 8 electrons, right? What are the molecules carrying more than 8 electrons known as?
Mm. Mhm.
Hmm?
The um,
They are known as hypervalent.
mm,
Is it clear?
okay, sir. Yes.
Hypervalent, right? And what are the elements uh, which have less than 8 electron after bond formation?
Mm,
Molecules which do not follow octet rule. They can either be hypervalent or hypovalent, right?
yes, sir.
Hyper
Mm,
means more or less.
more. So there's extra.
More. Yeah. Hyper means more. Got it?
Yes.
More than 8. And hypo means less than 8 electrons.
Yes.
Got it?
Yes, sir.
These are the exceptions to the octet rule. Clear?
Yes, sir.
Hypervalent and hypovalent. Hypervalent 8. Can you give me examples of hypervalent molecules which carry more than 8
Mm,
electrons?
mm,
Actually, they belong to third period. Second period
mm,
element cannot have more than 8 electrons. Okay.
yes, sir.
Because
The
second cell
hyperwell.
can have maximum 8 electrons, right?
Yes, sir.
So they belong to third period. So can you give me some examples of those?
So hypervalent. SO3 to
SO3, yes. PCl5,
yes,
very common example, right? How many electrons
yes,
are there for phosphorus?
5.
Total phosphorus atom is having 5 valence electron total after bond formation. Common electrons of the bond. I want to know that why it is called hypervalent. Got it?
Mm,
How many electrons? So each of after the bond formation, the phosphorus and chlorine, both electrons will be counted because covalent bond is common to both, right?
yes,
So 10 electrons, 5 bonds are there, 10 electrons. SO3, how many bonds are there? Total electron. To know whether it is hypervalent or hypovalent, you need to you need to calculate the total electrons. Is it clear or not?
Yes, sir.
Got it?
Yes, sir.
Now, so 10 electrons, phosphorus is there, sulfur is there, lot of third pair element. Hypovalent is, for example, BF3. Boron is fifth element, so 3 valence electrons are there. It is going to form 3 bonds, right? BF3. Is it clear?
Yes, sir.
So I hope this is clear to you. BF3, how many electron
Yes.
total after bond formation?
Mm,
Of the covalent bonds total?
sir.
How many bonds are there? 3. Okay,
Yes.
total 2, right?
Yes,
So
sir.
how many electrons are there? 6. They are less than 8 electrons, right?
Yes.
And there are some odd electron species also. What do you mean by odd electron species? As the name indicate, odd electron.
Very unique.
They are covalent species, but they all the till now we have seen all the electrons get paired up, right? You are seeing this. Can you see? All the
Yes.
electrons are pairing with the electrons of other atom, valence electron, not all. All the valence electrons are getting paired up with the valence electrons of other atom in order to complete the octet. But sometimes you have more than 8 electrons after bonding, or more than 4 bonds. So wherever you have 5 bonds, 6 bonds, right? There you have,
Yes.
or SF6 if you take. Okay, so these are the species where the octet is not being, octet rule is not being followed. For example, how many bonds are there on the sulfur? 6. So it is carrying 12 electrons, right?
Sir.
Okay, so these are a hypervalent and hypovalent, and odd electron means if you have that unpaired electrons left, single electrons, odd electrons left on the atoms, which is single electron which is not bonded to any other atom. So you have those molecules also. For example, if you take NO, how will you know that this is an odd electron species?
Mm,
So NO is nitrogen. How many valence
yeah.
electrons are there?
Right.
Nitrogen valence electrons are 5.
Yes, sir.
Got it. Oxygen, how many electrons are there? It is
Six.
the eighth element, so 6, right?
Yes, sir.
Oxygen need to bond 2 of its electron to make it 8. Got it?
Yes, sir.
Clear?
Yes, sir.
So now you can see this. Can you see that one electron unpaired left,
Yes, sir.
and this is the odd electron species, okay, where the total number of electrons are odd. Clear?
Yes, sir.
Okay. So these are the exceptions to your octet rule. Okay, so it doesn't mean that everybody will have a complete octet. Now we have seen there are atoms which is which are there and which are actually not following the octet rule, right? Yeah. So this is the drawback of the octet rule. There are atoms which do not follow octet while they form the bonds. Either they have more than 8 electrons or sometimes they have less than 8 electrons and sometimes they are actually odd electrons, right?
Yes, sir.
Okay. Next, let's move to the ionic bond. Okay, we have seen when the ionic bond is formed.
By completely gaining or losing of electron.
Yeah, so by it is formed between a metal and a non-metal by loss and gain of electron, right? And how we form a electron. We have seen some of the example like NAF we have seen, right? It is formed between the metal and a non-metal. Okay, it is also known by the name of electrovalent bond. How will you define it, Navila? Just quickly tell me.
The bond formed between metal and non-metal ionic bonding.
Yeah, it is. Yeah, so it is more thing you need to do. Somebody may tell you that okay, bond form. Somebody may ask you, is it by sharing or the complete transference of electrons?
The complete
Yeah, complete transfer of electrons from metal to non-metal, leading to the formation of
ionic bond.
a cation and an anion. Right? You will say it like this. And the cation and anions are held by electrostatic force of attraction, and that electrostatic force of attraction is known as ionic bond. Clear? I hope this is
Yes, sir.
okay, right? So NAF I have already told you. Let's discuss one more example. Suppose if you try to form calcium fluoride, how you are going to do that? Just quickly tell me. Calcium, the atomic number is 20, right?
Yes, sir.
So how you are going to write it?
Mm,
20 is 2, 8. I will write it separately. Okay. Calcium is 2, 8, 8, and 2. Got it?
Yes, sir.
So how many electron calcium will lose?
2.
Yeah, 2, that outermost 2 electron. Not those 8, right? Not from the inner shell.
Yes, sir.
So if the calcium loses 2 electron, what it will become?
2, 8.
Hmm. It will become,
Argon.
pardon? It will become a cation, positive cation, right?
Okay.
Now it will have complete octet. Okay, it is a metal, so that's why it lost its electron. And what energies will be required? Delta H IE1 plus delta H IE2. or delta IE2. Actually, the first and sum total of first and second ionization energies. Is it clear?
Yes, sir.
Right? So that will be uh, required. Third ionization energy is going to be very high because electron is removed from the inner shell, so that will require a lot of energy. Right? Clear? And similarly, what will happen to F2? F2 is gaseous. First, you need to give
Hmm.
bond dissociation enthalpy, right? F2.
Mm.
First, you will break the bond. It will change to 2F atoms. Got it?
Yes.
And those 2F atoms, what they will are they negatively charged now? No, but they will become negatively charged, right?
Yes.
Is it clear or not?
Yes, sir.
So by accepting one electron will be accepted by each protein atom, right? Electron gain enthalpy, okay, delta EGH, twice of electron because there are two chlorine atom, two more. That will be needed. Is it clear? So you have calcium plus ion and you have two chloride ion, right? You will add them together. What they will become? CaF2, solid, right? And once because these are cations and anions, and you know when they combine together, lot of energy is going to get released. Is it clear or not? Lot of energy will be released. Okay, that energy is known as lattice enthalpy. Lot of heat will be released. Okay, and it will form. That's why the compound will be stable. Okay, CaF2 will form. Okay, but suppose if they don't ask you the energy, just write these two equations, add them together. Ca plus 2F gives Ca2 plus and 2F minus, and they will become Cf. That's it. Got it? Is it clear or not? Am I audible?
Yes, sir.
Nabila? So it is going to become Cf, right? So, and this lattice enthalpy is because the cations and anions are placed in an ionic compound. They are actually placed next to each other. Okay, so that arrangement is known as lattice. Okay, I will show you in a
Yes.
minute. So what is an ionic bond? Cation and anion held together by electrostatic force of attraction, right? And what are the properties of electrovalent or ionic bond? Characteristics of ionic bond or ionic compound. Which common ionic compound do we see in our home? Tell me. Which common ionic compound do we see?
See.
In our home, which we use it in our food for cooking? Which ionic compound do we use? Sodium chloride, NaCl, right? Common salt.
Okay.
Got it.
Yes.
The one which we use, okay, in our food. So, what are the characteristics of ionic compound? Can you tell me? Ionic compounds are hard crystalline solids. They are hard and brittle. What do you mean by brittle?
Like,
They will crack, okay, if you apply force, but they are very hard, okay. Why they are hard and brittle? They are crystalline in nature because when you see their structures, there is a cation, there is an anion, right?
Yes, sir.
This is known as lattice, okay. So if you try to look at their structures, they will be like this, right? So each cation you can see is surrounded by anions, and each anion is surrounded by cations. Got it? As a result,
Yes, sir.
the cations and anions attract each other very strongly.
Okay, sir.
They are held together by electrostatic force of attraction, and that makes them very hard and brittle. If you apply the force required to break them is very large, but they will not bend, they will break. Okay,
Okay, sir.
is it clear?
Yes, sir.
Hard and brittle crystalline solids. Next is your do they conduct electricity
Yes.
in solid state or when they are dissolved in water?
Dissolved in water.
So why they will not conduct electricity in solid state?
The bonds are like closer, so
Yeah. So the ions can't move in solid state. Can they move?
no, sir.
They do not conduct. Why? What
Because the
reason?
bonds are.
Because the ions are completely surrounded by other ion. They can't move, right?
Yes, sir.
So this I hope is clear. They do not conduct electricity in solid state, right?
Yes, sir.
But when they will start conducting, when they become good conductor.
When dissolved in water.
Yeah, but they become good conductor. Why they become good conductor?
Because now they are able to move.
Yeah, the charges can move, they can transfer the electric current, right?
Yes, sir.
In aqueous state, what is aqueous state? Means it is dissolved in water.
Okay, sir.
Or in molten state. Molten state means you have melted them, okay? Then also the ions can move, got it, easily,
Yes, sir.
right?
Yes.
So they do not conduct electricity in solid state, but they are good conductors in aqueous state or in the molten state. I hope this is clear, right?
Yes, sir.
Okay. Next is what about their melting points? Do they melt easily, or will they have a very high melting point?
A high melting point
Yeah, they will have a very high melting point. Why?
to break the bond.
Because each cation is surrounded by anions, and each anion is surrounded by cations. Okay, they are attracting each other, holding each other very strongly. Got it?
Mm.
Due
Yes,
to
sir.
it, if you want to melt them, you need to put in a lot of heat so that they can go away. Okay. So these ionic compounds have high melting point, very high melting point. Okay. These are the common characteristics of electrovalent compound. Okay. Is it clear?
Yes, sir.
Okay.
It's clear.
What is lattice enthalpy?
Mm.
Lattice enthalpy is the energy which is released or which is required. Okay.
Okay.
Suppose if you take the solid ionic solid, if you give the lattice energy, 1 mole of ionic solid you can take. The ions will completely evaporate into the gaseous phase. Okay. But if you take the 1 mole of ions in gaseous state, when they combine, they will release that same amount of heat. Got it?
Okay, sir.
Is it clear? So lattice
Yes.
enthalpy is the amount of heat required to break 1 mole of ionic solid. Okay, so lattice enthalpy, if it is more, it indicates the attraction is more, right?
Yes.
And it indicate the ionic compound is very stable.
Mm.
Okay, but if the lattice enthalpy is less, it means the ionic compound has not stabilized much. Is it clear?
Yes, sir.
This is clear to you? Okay. Lattice enthalpy, and you need to remember the changes. Okay, what that names are. Ionization energy, two ionization energies. Okay, first you need to break the bond between. And we have seen it in the chapter of thermochemistry also as bond Haber cycle, if you remember, right?
Yes.
Okay, so let me end the class.